Hello, I'm Hanbo. In this presentation, I will present our work, E-Acrylic, Electronic-Acrylic Composites for making interactive artifacts. This work is a collaboration between Liu Xin, Yan Chiuan, and Clement Zheng from the Division of Industrial Design at the National University of Singapore. Electronic composites involve integrating electronic parts and circuits deeply into the structures of physical materials to give those materials computational features. In the field of HCI, these composites help broaden the materials and practices we use in interaction design, which therefore opens up physical interactive systems to more people and brings more communities into the development of computational systems. In this presentation, we present our research findings on the development and design applications of a specific electronic composite called E-Acrylic. Acrylic is a versatile material and exhibits many desirable qualities for industrial design. For example, it is transparent and lightweight. In addition, acrylic sheets are common material used for laser cutting within many maker spaces. Here is a common example where we use laser cut acrylic to build enclosures for an electronic device. As designers who work with acrylic daily as part of research practice, we saw the potential to use acrylic as a substrate for circuit and electronic components. In our research, we developed E-Acrylic, an approach to fabricate electronic composites out of acrylic sheets. E-Acrylic is made use of laser cutting and engraving along with other manual processes to incorporate circuits and electronic components into the structure of acrylic sheets. We also explored shaping these electronic composites into 3D objects through acrylic making processes, such as bending the material with heat and creating complex assemblies with joinery. We also adopted this approach as practicing industrial designers and explored different interactive applications that we could build with it to understand the capabilities and affordances of these electronic composites. Based on these applications, we reflected on our experience making them and proposed a design space outlining the possible design features of E-Acrylic. And with E-Acrylic in mind, we also discussed the implications of developing electronic composites for HCI. I will be sharing some of these details in the rest of this presentation. First, let me walk through the E-Acrylic fabrication approach with a short video. As you can see from the video, we use the various materials, tools, and making processes to fabricate E-Acrylic. These are things that were already familiar to us as designer makers. For instance, using the laser cutter to engrave circuit traces, using a brush to apply conductive paint, or using bolts and nuts to assemble parts together. With this fabrication approach, we explored a series of applications to see how far we can push the E-Acrylic to build different kinds of interactive artifacts. The first application is a game controller. With this application, we wanted to explore how bend a single piece of acrylic into a complicated 3D artifact. We also wanted to test out how transparent acrylic can diffuse LED light. Also, because acrylic is see-through, and we are engraving circuits onto it, those circuits really stand out. So with the game controller, we put a lot of effort into designing the circuits pattern on the flat pieces of acrylic. We also thought about how it would bend and conform with acrylic to shape the three-dimensional body of the game controller, which then contributes to the distinct visual appearance. Then we went ahead and tried out shaping some more curved 3D surfaces with E-Acrylic. We also wanted to test out how waterproof E-Acrylic really is. So we came up with this water level vase that can indicate how much water is inside using LED lights. For this setup, we embedded the circuits right into the body, connecting electrodes to the water and to the other components that need to stay dry. At the same time, we got inspired by sensing Kirigami, and we wanted to check out other ways to make complex three-dimensional structures with E-Acrylic. So we thermoformed this fishnet-like acrylic piece and made a lamp out of it. And we used opaque acrylic to hide the circuits and really emphasize the structure. Besides creating applications from a single piece of acrylic, we also wanted to explore how we could incorporate many different parts of acrylic into a single application. So we decided to try making a pinball machine using bolts and nuts as a main way to hold it all together. And since bolts and nuts are metal, we could also use them to conduct electricity across different acrylic parts, creating a circuit in 3 dimensions. In addition, in this application, we built a flexible acrylic structure to act as a gate, stopping the metal ball from the moving. And on top of that, it also serves as an electronic switch to detect the metal ball and light up the LEDs. After that, the compliant structure with E-Acrylic motivated us to look into more possible interactions and applications. So we built a cup warmer. In this cup warmer, we integrated a heating element into the compliant structure. When people place a cup on it, the spring-like structure gets pressed down, closing the circuit and turning on the heat. Besides thermoforming or joinery, we also got interested in stacking acrylic. So we decided to try something out and build this interactive contour map by stacking up layers of transparent acrylic. And since E-Acrylic lets us make circuits that go through multiple layers, we could extend the touch sensing from the touch screen to the surface of contour map. We laid out a series of touch points all over the contour map. When people touch these points, it activates the touch screen underneath and provides visual feedback right through the transparent acrylic. So, even though we tried out a bunch of different applications, we know there are still more out of there to explore, and we want to make E-Acrylic a thing that more industrial designers can get into. That's why we took a step back and looked at all the stuff we have done with E-Acrylic, then mapped out this design space. We cover everything from ways of creating 3-dimensional E-Acrylic objects to different ways in which electronics can be embedded. We detailed out these things in the paper. In addition, the applications reveals 2 major implications for electronic composites in HCI. One is how E-Acrylic integrates physical computing deeply within acrylic making practices. Our approach to E-Acrylic shares similarity to related work on developing electronic composites with different crafts, like textile, paper, and ceramics. We took those regular acrylic making techniques, like laser cutting and thermoforming, and made E-Acrylic based on them. And just like in other similar work, instead of just sticking electronic parts on the surface, we want to create an electronic composite that really embraces the versatility and creativity that comes with making practices. Another implication is the unique material quality of E-Acrylic, which designers need to think about. As shown in the game controller earlier, E-Acrylic requires designers to care about not only the functional layout of the circuits, but also how the circuit presents itself when it's placed on the acrylic. We believe this shift in how we perceive circuits will make designers more mindful of how everything fits together in interactive artifacts made with E-Acrylic. And that will open up even more avenues of expression in physical computing with E-Acrylic. So, to wrap up this presentation, we hope that this research provides a useful approach for designers to build interactive artifacts, and we are excited to see what others will build with it. Do reach out to us for more questions or comments. We would love to hear what you think. And thank you for your attention. Please check out our paper for more details.